Okay, sorry. Uh, okay, I will not take up the tool session. Maybe there is some issue with my tools. Okay, the last class, yes, yeah, in last class, really the power has created a problem, but today I think system and software is not compatible. Okay, so don't worry, I will take up the theory part. Okay, we should not waste the time. Okay, so as I mentioned in my last class, that we have to start thinking about the project. Okay, we have to start thinking about the project. Okay, so project part we will take up later on. Let me take up let me take up some other things with respect to the adder implementation. Okay, so as I mentioned that in my last that half adder, we have designed a half adder with help of NAND gates. Okay, all those who are new, you can please go through the previous class and you can see that how we have designed the NAND gates with NAND gates. Sorry, how we have designed the half adder. That is, this is my half adder. Okay, this is my half adder, and we have designed this half adder with help of NAND gates. That is a two maximum and minimum. Okay, so maximum is basically we required a 6 gates, and minimum we required a 5 gate. Okay, so now my question is for everyone. My question is for everyone. Why we call a half adder as a half circuit? Okay, why we call a half adder as a half circuit? Anyone want to try? Victor, we will provide you the tool. Don't worry. So why we call a half adder as a half circuit or half adder as a half circuit? Anyone want to try? Anyone want to try? Why we call a half adder as a half circuit? Come on. Any reply from your side? It can add 2 bits of no, no. This is it can add a 2 bits of data. No, both half adder is adding the 2 bit of data. Both half adder adding the 2 bit of data. My question is, or again, I want to recall that this type of training, this type of learning is totally a interview based learning. Okay, I will ask the questions, and by asking the question I will help you to explain the concept. No, it can add 2 bits of data. No, both half adder and full adder adds 2 bit of data. My question is why half adder is called a half circuit, and prove it, and prove it. Okay, no reply. Okay, so let me explain. My question is why half adder is called a half circuit or why half full adder is called a full circuit. Okay, maybe some of you knows, some of you may be aware of it. Okay, but here I ask you prove it, right? So let's take very simple example. Okay, so why half adder is called or known as called or known as half circuit. Okay, so let's take and prove it. Okay, this is my question. Okay, let's prove it. So let's add let's add two input of 2 bit. Okay, let's add two input of 2 bit. So what I will do here, I will take two input and two input. Okay, two input of 2 bit, right? So generally we add like this. Okay, so we have to add like this and this and this. Okay, so this is my, let me explain like this: A0, B0, A1 and B1. Okay, so this is my one half adder and this is my one half adder. Okay, because I have taken a two input of 2 bits, two input of 2 bit. As I ask, you have to prove why half adder is called a half circuit. This is my question. You have to prove it, not you have to say. You have to prove it. So while proving, I need a 2 input and 2 bit. Okay. So for the same, I will design the hardware also. That is a gate level implementation. Gate level implementation of both. So this is a gate level implementation. How? A0, as I mentioned, I am not adding this and this. Sometimes students are very confused because they thought ki we have to add whenever we are writing like this 0 1 0 1 1 1 0 1 1 1. That means you are adding from upper to lower, upper to lower, upper to lower bit, right? So the simple maths what we are doing. So my question is, you have to prove me why half adder is called a half circuit. So basic, so very basic understanding. This is my one half adder. Okay, this is my half adder 1 and this is my half adder 2. Okay, so we have to prove it. This is my half adder 1 and this is my half adder 2. HA1 and HA2. Okay, so A0, A1. So this is my half adder 1. Okay, and this is my half adder 2. Still I have not connected. Okay, I have not connected with any input, with any output, with any input. Your question is easy, but whenever interviewer will ask the simple question, you become start thinking very reply at very high level. You have to start thinking reply at very low level. Okay, think lightly. Don't think at very high level. Okay, this is by HA2. Okay, very simple. HA1, HA2. So if you add 1 plus 1, right, 1 and 1. So what happened? 0 will come here and this carry will come out. This is my carry or carry out. Similarly, you will add A0, 1 and 1. Okay, 1 and 1. So what happened? Your sum will be 0 and your carry will be 1. Right? Now my question is, as I mentioned here, you have another hardware. I ask simple question. Prove me why half adder is called a half circuit. So if you are adding, if you are adding these two with the two half adder, okay, my reply is, if you are adding these two with two half adder, okay, then you required another half adder. So the now question is very simple. You don't have any third pin. Okay, you don't have any pin, okay, which basically adjusts the carry out. Okay, if you are realizing this combination with two half adder, if you are realizing this two combination with two half adder, then only you are able to prove it. That in my second hardware, that is a addition of HA2, okay, that is B0 and B1, B0 and B1. That okay, we can adjust this and this, no problem. But the problem is that you don't have a extra pin at HA2 side to adjust the carry out. Okay, so the simple reply is half adder is called a half circuit because half adder don't have an carry in pin to adjust, okay, to adjust the carry out coming from previous adder. Very simple. Okay, so you can also reply this theory, but if I ask you to prove it, my question is, whenever the candidates are sitting in front of me, I will ask him or her to prove it. Okay, not to just say the theory. Okay, so I'm not saying that this is 100% correct, but there is no other way to prove it. There is a only way to prove it, to add two bits of two input with two half adder. Okay, or if you have a full adder here and if you have a half adder here, then again same thing. You don't have the carry out. You don't have the carry in pin to adjust the carry out. Okay, so two three questions. There are still many questions later on. Whenever I will complete the mux, okay, then through mux we will design the adder. Adder means both half adder, full adder, both. Okay, so this, so mux I'm not going to touch now. Okay, I have just finished the half adder. Half adder, this is my half adder. Okay, now with the help of half adder we are going to make a full adder. Okay, so now the question is, let's have a truth table of half adder, full adder, sum and C out. Okay, now we will have some interesting questions here also. 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. Okay, so simple. Now, now the question is here, if I am asking you, sir, what is the function of adder circuit in design? What is the function of adder circuit in design? In my project, right? You are talking about my project. So in my project, the adder will basically add the two input. Okay, two input of 4-bit. Okay, in my project, the project which we are planning, two input of 4-bit. Okay, a 4-bit with any sign. With any sign means that A and B can be positive. Okay, positive. A and B can be negative, positive, negative, positive, and negative, negative. But so we are designing this half adder. We are designing the operation part. We are designing the operation part. So this is a function of my half adder to add the two input. To add the two input, and the input can be in form of bits 0 1, right? So sometime I ask the question with the candidates, tell me the difference between half adder and full adder. Okay, I will tell you logical and concept का क्या meaning होता है. Let me first explain this. So if I ask the question from any student, give me the basic difference between half adder and full adder. So what they basically mentioned me ki half adder is a 2 input and full adder is a 3 input. Yes, of course, with the help of truth table, it is look like a 3 input. Okay, with the help of truth table, it is look like a 3 input. Okay, but at the same time, if I ask, let me make the hardware, let me make the symbol. Okay, this is my A input, this is my B input, and as per you, this is C in, right? As per you, this is C in, and this is sum and C out. So if you are giving A1 and B1, okay, so from here, right, or, originally from here, where is the third input? Is C in, you are forcing, this one you are forcing. Okay, forcing means you are giving the value. This one you are forcing. But this C in, automatically, this C in, the first time, is this C in you are forcing somewhere? No, this C in you are not forcing. Okay, so initially you are giving this C in as a ground. Okay, initially you are giving this C in as a ground. You are not forcing it. Okay, this is my actually reply. So both half adder and full adder both are actually two input device. Okay, to input multiple bit. Okay, to input multiple bit. Please remember this. Both are to input multiple bit device, but here we have taken C in because, as I mentioned in my previous adder, half adder, that half adder is called a half circuit because half adder don't have an extra pin which adjusts the carry out signal generated from the previous adder, right? That is why we have assumed the pin number, the pin C in, we have assumed that if any such value will come, either it's come as a 0 or either it come as a 1, then what happened? Okay, so you can think in this like you can take up in this way also. Suppose that let's take A and B 0 0 0 1 1 0 1 1, and suppose that by default, if another value you are assuming it, okay, again you are assuming it. If you assume something, this will come here, and with respect to these three variable, with respect to your three variable, you will have some hardware. Okay, so if you assume it, okay, so that is why we have considered this as a third interface, or as a third input in terms of your understanding. So 0 0 0 0, okay, and then 0 0 0 1 1 0 1 1 1 1 1 1. So in this way also you can take up, right? If you assume as a third interface or a third signal, then you are considering the three different variables, and if you are considering three different variables, then you have a eight different options, and this is the eight different options. So either you take like this, or either you take like this. This is my C in, this is my A, this is my B. So why I am telling you so confidently that both adder are two input device, because we have already implemented the design, okay, with respect to our understanding on FPGA, and we have received the real time hardware output. Okay, we are not giving you any bluff reply. This is something which is proven, right? So this C in is not a pin. Again, this C in is not a pin. The pin is that which you are forcing some value 0 1, which you are connecting with some voltage source, Here A and B you are connecting with some voltage source, or in terms of digital you are forcing the value. The C in is generating automatically. Okay, why? Because as I mentioned here, this is C in, right? I told you this C in is the value which is output, C out is generating from the previous and connecting to this input. So this is not a third pin, this is not a real time third input. The real time inputs are A and B only. Okay, so keep this in mind. If anyone is asking what is the basic difference between half adder and full adder, don't tell them that half adder is a two input device and full adder is a three input device. Don't tell them. Tell them half adder is a two input, full adder two input. The basic difference is half adder don't have a pin which we call as a carry in pin, which adjusts the carry out signal generated from the previous adder, as well as the full adder has a pin which is known as a carry in, and which adjusts the output generated from the previous adder, C out. I hope this is clear. Okay. Yes, this is random. No problem. This can be random. And whatever you will get the output, the realization of the circuit, you will get just a difference between AB. It can be AC, BC. It can be C in A. So depend on your equation. Sorry, the random. If you put A here, B here, C here, and if you will derive with the help of K map, then the equations input will be different. Okay, that position of the input will be different. Okay. Now, so I will take in this way A, B, sum and C out. Okay, so 0 0 0 1 1 0 1 1 0 0 0 0 0 0 0 1 1 0 1 1 0 0 sorry 1 1. Okay, 1 1 1 1. Okay, now this sum 0, carry out 0 1 1 0 1 0 0, and this is 1 plus 1 is basically 0 1, and again you will add 1, then this will become 1 1. So this is 1, this is 1. Okay, simple. A and B, 0 0 1 0. Simple maths. Okay, if you don't know uh, that, please go to the last class. This is 1, this is 1. Okay, so as I mentioned in starting, I will not touch the K map, I will not touch the realization of any truth table in terms of with the help of K map and drive the circuit. Okay, because I know this is a method and you know very well. Okay, so what is the expression, like what expression you will achieve with help of K map is that this is your sum is A XOR B XOR C in, and your carry out will be AB plus BC in plus C in A. Okay, so what 0 and 1 for C in? What is the question? What is the function हो गया? Okay, this question is pending at my end, Mohit. What is the logical and concept का क्या meaning होता है? So C in is a random, sir. So C in is a random, sir. Yes, C in is a random or it is a fix, as I mentioned here. So C in can be a random, right? But if logic 0 and A B means ground, while logic 1 means no. But if logic 0 for A and B, no, Victor, I can't understand what you are asking here. Please explain in better way, or please let me know in better way. What is 0 and 1 for C in stand for? 0 and 1. 0 and 1 is basically a random value, as one of your colleague mentioned here. So we are just assuming, okay, if we are taking A, B and C in as a third input or as a third interface or as a third signal, then we are assuming, right? So A, B, and this is a third one. But again, this is not you are forcing someone, right? You are getting automatically previously. Okay, so you are assuming, okay, if this is a third variable, then you have a 8 combinations, right? So what is the expression? What is the circuit of this? Circuit is A XOR, this is your, okay, ये all these you have to basically design on tool. Okay, you have to design these thing on tool. Okay, so this is your 0 0 0. This is your basically A, B and C in. A, B and C in. This is your sum and this is your C out. Okay, if you don't know the K map, you just go through the basic tutorials from your book or from your college assistance. You can take a college assistance and you can solve this. Okay, so from where you have received this expression? You have received this expression with help of K map, and I have just converted from this expression into the hardware. Now my question is again same thing what we have asked for half adder. How many number of how many number of NAND gates? Again the question is same. How many number of NAND gates? ठीक है required to make a 1 bit full adder. Come on, tell me. How many number of NAND gates required to make a 1 bit of full adder? Okay. How many number of NAND gate? Anyone please try. Tell me. Sure, Mohit. Now tell me, with the help of the same concept which I discussed in last class, how many number of NAND gates is required to make a one bit full adder? This is a interview question. इससे ये पता चलता है कि if you know the question, if you know the reply, that means you have explored, you have explored your digital subject. Okay, you are not a person who has just believe in solving the questions and clearing the exam. Tell me, how many number of NAND gates? Come on, very easy. 12. Shubham. Okay, Shubham, this is the maximum or minimum. Now the question is, okay, I will add now two more thing because you have not asked me, because you have to ask me as a, if I am an interviewer and you are my student, then you have to tell me, uh, ki, sir, you are asking about maximum or minimum. Okay, you have to ask me, sir, you want to know the maximum number of NAND gates or minimum number of NAND gates? Okay, so the maximum number of NAND gates and minimum number of NAND gates. Now, still any idea? 18. No, 12 again. 12 is maximum or minimum, or 18 is a maximum or minimum? Shubham, you are telling me 12 is a minimum. Okay, you are telling me 12 is a minimum. And Parvati, right? You are telling me 18 is a maximum or minimum? Tell me. 18 is a maximum or minimum? Minimum. Okay. Okay. So let me explain here. The maximum number of NAND gates is, again, this is a very good interview question. Maximum number is basically 20 and minimum number is basically 9. Okay. So now we are entering into the engineering phase. We are called as an engineer, we are studying the engineering, but we are very rarely we are doing any engineering things, right? So now we will do the engineering things in our home. So what we have to do here, we have to optimize this 20 from 9. How? I will let you know. Okay, let me first let me first add. Okay, now let me tell you how this is going to be a 20. Okay, so XOR is made up of 9 gates, 4 NAND gates. XOR with 4 NAND gates. Okay, then AND is with 2 NAND gates and OR with 3 NAND gates. So 4 plus 4, 8, 10, 12, 14, 14 3, 17, and 17 3, 20. Okay, 17 3, 20. Okay, see, this is your A, B, and C in, and this is your sum, and this is your C out. Okay, now okay, so this is sum, this is C out. This is very simple. As I mentioned, this is my first XOR, this is my second XOR, and this is my AB, this is my BC in, this is my C in A. So this is your A XOR B, and this is your A XOR, sorry, this is your A XOR B XOR, and this is your C. Okay, this C in is coming from here, right? Now this is your AB, this is your BC in, and this is your C in A, right? Now this is your AB plus BC in A. Okay, and now this C in A and this is your final C out. Mean to say that AB plus BC in plus C in A. Now the question is, you have to optimize. Okay, इंजीनियरिंग सीखनी है ना, तो इसको ऑप्टिमाइज करो. If you don't, if you do first, if you take a first attempt, second attempt, and if you give up after the third attempt, then think for any other domain. Don't come in this domain. Very simple. But if you reduce one gate, it will give you the motivation. Then you will reduce the 2 gate, then 3 gate, then 4 gate, then 5 gate, and then finally you will come up to the 9. Okay, so if you remember in our half adder, how we have reduced, let me once again tell you, okay, how we have reduced the same approach. Why I am telling you? Because this is very small. Okay, how we have reduced the gate. I will not give you the exact solution. If I will give you the solution, you will not gain the confidence. You have to try. Okay. Sum and C out. Right. So this is what AB, this is A, this is your A dot B bar. Okay. And we are getting the same thing here also, A dot B bar. So why not, if we reduce this, if we cut this and we connect from here to here. So hence we have reduced one gate. We have detected one gate. Similarly, you have to follow the same approach here. Okay, you have to follow the same approach here. Now you can do one thing, you have a full right. Okay, what full right you have? Right, what full right you have? For example, I have taken AB plus BC in plus C in A. Okay, so you have a right, like either you can bring this line, means you can design or you can define the circuit in such a way that the first one is your BC in A, that is BC in A, second is one your C in A, and third one is your AB. Okay, so it is up to you. You can reshuffle it. Okay, it is not mandatory. It is not mandatory to do in this way, AB plus BC in plus C in A. No, it is not mandatory. You can do like BC in A, C in A, and AB, so that you can think not with respect to any method. You can think with respect to any hit and try. Okay, again, a method you can forget, but hit and trial concept you never forget. Right? So now you have to reduce. The hint I can give you, you cannot reduce this. You cannot reduce this. Okay, you cannot reduce this. I will tell you the solution in next class, but you cannot reduce this part. Okay, you have to reduce from here to here, and you have to keep any one gate and the connections of one gate from any of the line. Means I mean to say that either either you have to make this short. Okay, you can do the shorting here. You can do the shorting here, and I am just giving you the hint, right? I am not giving you the solution right now. I am giving you the hint so that you go and think. You have a 2 days, and you have to take this line, and you have to connect this line either over here, from anywhere. Okay. So what you can do, you can think in digital format only, right? You can't do the everything in terms of hit and trial. Okay, this is also a hint for you. Okay, you cannot reduce all the gates with the help of hit and trial. The hit and trial is what? Okay, this is what giving. This is giving a buffer. Okay, so if any output is coming from here to here, then why we need these two gate? Okay, this is also acting like a buffer, and this is also acting like a this one, and this one is also acting like as a buffer. Okay, so why I need this and this? Okay, try to understand. Buffer means how the buffer has been designed with help of NAND gates. Okay, buffer designed like this. So 1, 1, 1, 0, 0, 0, 1. So if any signal is coming from AB here, then automatically it will come AB here. Okay, from here to, sorry, not here, here. Okay, so just for an idea, 1, 2, 3, 4, and 5 and 6. I have reduced the 6 gates. So 20 minus 6 is 14. 20 minus 6 is 14. Now you have to reduce 5 more gates. Okay, you have to reduce 5 more gates to make it 9. Okay, so for 9, what you can do, I'm giving you the hint. You can start thinking about this and this part as a first and second, and AB part as a third. Why? Because you have to take some input lines from here to up to this part. Okay, so this is just a hint for you guys, not giving you the exact solution. Exact solution we will try to work out in next class, in next upcoming class. Okay, so this is called an engineering approach. Sometimes some student asking me, sir, why we are doing this when there is a tool? Okay, when there is a tool. See, very simple question. He is correct. Sir, why we are optimizing this when we have a tool, or when we know the solution? So the question is very easy, very simple. That when you are sitting in front of interviewer, you don't have any tool, right? So if you are skilled, if you are logical, you can utilize the tool in very efficient way. If you are not skilled, if you are not logical, you cannot utilize the tool. So they don't want a labor there. They want an engineer, right? So that is the reason you have to try this. If you are not able to do the basic optimization, you are not fit for the industry. This is in very simple way, right? I am not asking you to reduce the 2000 gate into the 20 gate. I am asking you to reduce the 2025 gate into a 8 or 9. Take 1 day, 2 day, 3 day, 4 day, 5 day, any day. Okay, so this is your what? uh, Optimization. Okay, one more question basically interviewer ask. Okay, one more question basically interviewer ask. What is that question? The question is, they will design, basically the interviewer will take the pen and paper, see in A and B, 0 0 0 1 1 0 1 1 0 0 0 1 1 0 1 1 0 0 0 1 1 1 1. Okay, sum and see out. 0 1 1, sorry, 1 0 1 0 0 1, see out 0 0 0 1 0 1 1 0. Okay. So what interviewer will ask you? Interviewer will ask, okay, with help of two half adder. Okay, with help of two half adder. Okay, with the help of two half adder, design full adder. Okay, so maybe few of you know, but exactly what I want to ask here is something different. With the help of two half adder, design a one bit full adder. So generally, the solution is given here. Okay, solution is here. This is my. This is the solution. Okay, this is the solution. Sum A, B, C, or in terms of block level, A, B. See, question. I have not completed a question. Wait. A, B, sum and C out. Sum and C out. Now, if interviewer will ask, okay, design a full adder with help of two half adder. Generally, everyone will do the same thing. Okay, if he or she knows this designing earlier. Okay, if he or she had designed this particular concept earlier. Okay, but now the question is, or I will ask as an interviewer, why we have connected this to this? Okay, why we have connected this one, this C into my this A and B? Why? Okay, what makes you to connect this? And why we need to connect this half adder? Okay, so think it. In this class, I am not going to give the solution. You have to think it. So if anyone is going to explain, again you can use your algebraic equations, sorry, your Boolean algebra. You can use your pos or whatever. You are free to use, but you have to give me the solid reply. Why we are connecting this C in with this, and why you are connecting this full adder, right? So if you know, good, very good. But if you don't know why, then it is very bad. Okay, so if this thing taught me in my BTech, maybe you have learned this thing in your BTech, but the question is that at that time I have not asked why, and in your case you have not asked why. Maybe your teacher had explained that, maybe, but you have not tried it. Okay, you have not explored it. So explore this. Okay, so in next class I will take up both things, this one and this one. Okay, we will optimize both this one and this one. Okay, so let me take up some question first. Uh, First, Mohit, let me explain why you are asking the what is logical and concept. Okay, so still one topic is pending, a 4-bit adder. Okay, so logical and concept. My dear, concept is just a theory. Okay, theory. That is a theory. That is a concept or theory part. Like what is gate? What is the AND gate, OR gate? What is the truth table? How this truth table is work? Okay, and logical approach is something called hit and trial. Okay, in my first class, I told you how to make a AND gate with help of NAND gate without shorting. Okay, without shorting, right? So we use some. So there is no definition to become a logical. Yes, definition. Yes, theory is connected with the logical, because if you don't have a theory concept, you can't do any hit and trial. So in short, hit and trial is a logic building approach. Okay, logic building. So logic building you only do with help of your theoretical concept. Okay, so what theory is involved in making the logic? There are two types of logic. One is a theoretical logical. Theoretical logic. What is that? Your Boolean algebra. Okay, that is all method. I am telling you in my terminology. Okay, in terms of theory or concept, things will come as a method. Okay, so if you know the method, okay, if you know the method, you are building the logic basically. Okay, because method is built up of different steps. So those steps combine and make one method. So you can either take this method as a logic also. But in my terms, hit and trial, there is no method, there is no K map. Okay, there is no Boolean algebra, there is nothing. Just you are connecting from here, okay, from here, and you are putting the value and you are checking the output. Okay, so this is called the hit and trial approach, right, Mohit? Okay, so let me take one by one question. We have gone through about 6 or 7 classes, man. Okay, two conditions, two continuous not will remove. Shubham, you are saying that two continuous not will remove. Yes, correct. Two continuous not will remove, not get will get removed. Yes, correct. Sir, please also explain how to understand topic and meaning of concept and logic. Okay, and one or gate is required more. Sir, how to understand any topic? Okay, Mohit, you are from which year? Which class or which year? First year, second year, third year? Okay, so what is the time now? Okay, 7:10. So this is theoretical logical. Now let me explain what is the 4-bit adder. Okay, 4-bit adder means 1001 and 0110. You have to add it. 101, 011, 101, 101. Okay, this is your output. Okay, so how it is basically A0, A1. We are going to design the hardware of 4-bit adder up to the 8-bit adder in tool. Okay, so wait for the turn. A0, A1, A2, A3. Okay, B0, B1, B2 and B3. Okay, so this is one full adder, this is one full adder, this is one full adder, and this is one full adder. So if you want to make a 8-bit, you can start adding like in this way: A4, A4, B4, A5, B5, A6, B6, A7, B7. Okay, so this is your the simple solution of your 4-bit adder. Basically, how the 4-bit adder look like this. Okay, so now the question is, let's design the hardware of 4-bit adder. Okay, so this is your, as I mentioned, this is your one adder, this is your second adder, this is your third adder, this is your fourth adder. So A0, B0, A1, B1, A2, B2, A3, B3, right? This is your C in, this is your sum, okay. This is your C in, this is your C in, this is your C in. Okay, so now again, as I mentioned earlier, that that half adder, full adder, both are 2 input, and full adder is not a 3 input. Okay, so here a best example: if you are making the 4-bit adder with help of 1-bit full adder, okay, then this C in is actually you are keeping this ground. because you are not considering this input is considering any output as an input from any previous header, because this is the first one. Okay, so you are considering this as a ground. So you are in a reality you are forcing only A and B, and this C in is basically, see, this C in is basically this is your C out going to C in, this is your C out going to C in, this is your C out, this is your sum 0, sum 1, sum 2, this is again C out goes to C in, this is your sum 3, and finally you have C out. Okay, so if you are adding 1 1 1 1 plus 1 1 1 1, okay, then 0 and 0, this carry is seen. This is basically your C out goes to C in, C out goes to C in, C out goes to C in, so 0 0 0, and finally you have 1. So this is considered as your C out final, and this is considered as your sum S0, S1, S2, and S3. Okay, so this is a simple implementation of full adder, 4-bit adder. If you want to make it 8-bit, you have to make it, you have to add another 1 bit, 1 bit, 1 bit, 1 bit. Okay, so this is, we are going to design each and every block. In my calculator, sign calculator project, in my sign calculator project, right, in my sign calculator project, you are going to design a 8-bit adder. Okay, 8-bit adder with clear input. Clear input means this is your 8-bit adder. This is your A input. A has data 0 to 7. Sorry, 8-bit adder means, okay, we can take up like this. B has data 0 to 7. And this is your clear. And this is your scene. And you have a sum. Okay, 0 to 7. And last you have C out. So this A7, B7, so this is your 8-bit adder. You need 8-bit adder. So when you give a clear 0, when you give a clear 0, you will not receive any output. The entire output will be 0, 0, 0, 0. Right? And you have to disable this from 0 to 1, and then only your adder will work. Right? Then only your adder will start working. So this clear is going to play a very, very crucial role. Clear. Right? So this is just a start of our first project, and first project का जो first part है, that is called a 8-bit adder. Okay. So one last question. Please tell how to understand any topic, which approach I will follow, because learning the things mean rattabaji, but I do not know how to understand. Very good. So if you want to learn something, Mohit, you have to first start asking the question why this is coming. Okay, why this input is, how this output is working, or how this circuit is working. Right. If you will go to my, if you will go through my first class, we are not focusing on any theoretical, like I have mentioned that not to make the notes. Okay, what happened here, nowadays you are making the notes and you are not thinking. Actually, if you're not thinking, that means there is no question coming in your mind. You are just making the notes, and once you make the notes, the next class will start of any other subject. So again, you have not a time to think what has been taught. Okay, so if you, some sessional will come or some paper will come, then what you will do, you will just go through it the previous topic, and again you will not think. So in this way, you have not developed the approach of logic building. That is why the electronics engineering look like a tough, because we are not thinking at the logic level. That is why very few people are here in this industry. If I tell you that the ecosystem of VLSI Training Institute are dealing with the only the thousand engineers. Okay, we are not dealing with the lack of engineers. We are dealing with the thousand of engineers. I can prove in very well manner way. Okay, let me prove. in JE, okay, suppose 10 lakh people has given JE, appeared, they have clear, including everything, IT, non-IT, everything. 9 lakh will join non-core. You are easy to get a job. Nothing wrong. I'm not against any domain. Okay, everyone is a part of this ecosystem. Okay, we are totally depend on CSIT, and CSIT is totally depend on us because we are producing the hardware. They are producing the software on those. Right, but here the chicken egg concept is not here कि कौन पहले आया मुर्गी या अंडा. Okay, here the ultimately the hardware comes first in picture. No hardware, no software. Okay, so in 1965, in 19, if you remember that US has sent its first satellite is somewhere in between 1950. At that time there is no craze of software, right? At that time it is there, software is there, but not so huge requirement because the hardware is doing everything. Okay, so 9 lakh people went to CSIT across India. Only 1 lakh people think for core. Why? Because they have not received these branches. They have not received these branches. So out of 1 lakh, whoever has joined the electronics, I'm talking again, the 90% people are again thinking about CS and IT. Okay, so 90% people, 90%, that means 1 lakh ka 90,000 people thinking about CS and IT. So how many people left? 10k. In 10k, again the 90% people thinking of government jobs, PSUs, okay, business, still many things. Okay, yeah, not to do anything. Only 10% still left, and 10% is actually 1,000. This 1,000 is basically joining the this industry because they have decided. How they have decided? Because they know what is VLSI. Some of because their parents are working on electronics, their brother, cousin, whoever is working on electronics, that's why they have an interest on electronics. Okay, or when they join the electronics because they have not received this EC, CS and IT, they start thinking of this core domain. Okay, so I am giving you this clear picture from my experience. Okay, from last 11 years, I am feeling that this this number is still degrading. And again, one more thing, the biggest thing, that all the top scorer, okay, after in JE ranks, all the top scorers are joining. There are total 7 domains. One is computer science, one is computer science and engineering, then computer science in data science, computer science in AI ML, okay, then computer science in IoT, and in last EC will come. Somewhere IT will also come in picture. So 1, 2, 3, 4, 5, 6. We are at 7 number. Now tell me how this, why not this industry will affect? Because all the brainy people, all the good engineers, all who have scored the good marks, I'm not saying anything to you. Please don't take it another way. Okay, I'm not saying anything to you. You have opted the EC. That is why you are here. Some 20, 30 people. So the level of the people who is joining the EC is already low. Okay, already low. Still, see how much effort I have to put. Okay, the person who has taken EC because of not interest in EC, but now he has to make the career in EC. So how much effort I have to put? The people like us. So this is the real picture I'm giving you. Okay, so don't take in other way. And what is the advantage of this? Of this low, like low turnover. The low turnover is that you have a huge requirement. Okay, but you have a less people. If you have a 10 job, you have only 1 people. This is the advantage. So one person can get the 10 job. Okay, but in other domain there is 100 or 200 and 400 or 500 or 10,000 job. Then there are lakh of people are there. So Sometimes you have advantage, sometimes you have a disadvantage. And why people are not coming to this domain? Because it's VLSI embedded required a lot of mehnat, lot of efforts, lot of discipline, lot of ethics, okay, lot of honesty, which not easy I can get in any students. Okay, so it is tough to create an engineer in VLSI domain. But if anybody had decided in terms of money, in terms of finance, in terms of commercial, the VLSI is the best. My people who have joined the VLSI 2014, if they have crossed their 10 years, okay, their salary is 10 year into 7, okay, between 60 to 70, including the SOP, ESOP. Okay, so domain is really very, uh, like a very good domain, I can say, in terms of paisa and in terms of challenge. Okay, really very fantastic domain. So think about VLSI means you will never face any financial problem. Okay, but again, you have to forget each and everything to become a VLSI engineer. If you can do it, you are most welcome. Okay, so this is all from my side. The question is, so do you offer any training to teachers in domain to carry out research? Yes, we have started a faculty development program, but I have stopped because I am waiting for more information from Cadence, because we are Cadence using the tools, especially on circuit design and full custom layout. Okay, so yes, we are providing the training to the colleges, faculties, research scholars, PhD, lab assistant, everyone. I'm not able to understand that if we add 111 carry out, why you write it? Okay, Avik, very simple maths. 1 1 1 1 1 1 1. Okay, so if you add 1 and 1, it will become 0. The carry will come here. Okay, again, this. Okay, okay, sorry, I done mistake. 1 and 1. Okay, sorry. Thank you for correcting. This now 1 1 1 means 1. Then again, this carry will come. 1 1 1 and then this carry will come. Thank you, Avik. So this is the solution. Okay, this is your carry out, and this is your S0, S1, S2, or S3. Got it? Thank you, Avik. Okay. What about embedded? Yeah, I will take some time to mention embedded, but in embedded, generally we focus on interface. Interface, like we start with LEDs with the help of embedded C, LEDs, SSD, LCD, PWM, motors. Okay, and then keypad, UART, SPI, and I2C. Okay, so these things are required to understand the embedded concept. Okay, so this is all from my side. Thank you, and really, it's really a very good session. I really shared a lot of information. And sorry, in starting, our software is crash. So I will resolve it, and in next class, we will start working on tools. We will give you the demo how to make the 8-bit adder from single XOR and AND. With the help of XOR and AND, how you can design the 8-bit adder, not on paper, on tool. Okay, so this is all from my side. Thank you, everyone. Thank you.